Good morning, ladies and gentlemen, and welcome to section 9.1 of Mrs. Quinn's Geometry. Today we're going to talk about some theorems, and then we're going to plug values into formulas. So let's talk about the unique plane assumption. Through any point, 2 points, there's exactly one line. I think we've already talked about that one. The number line assumption says that every line is a set of points that has a one-to-one correspondence with the real numbers, or i.e. With the number line. So any point on your line could correspond to 0, and any point on your line could correspond to 1. Your dimension assumption says that given any line in a plane, there's at least one point in the line that's not on the plane. And given a plane in space, there's at least one point in the space that's not on the plane. So for example, if I have 2 points, I only have one line. And here for part 1, if I have some plane, there's at least one point in the plane that's not on my line. And if I have some three-dimensional space, I should be able to draw a plane and thus a point that's in the space, not on the plane. Hopefully those pictorials help. We have a flat plane assumption. If you have 2 points lying on the plane, then a line containing both of them also lines in the plane. And this one makes pretty good sense. If I have a plane and 2 points in it, any line that contains those 2 points is going to have to be inside my plane. And last but not least, the unique plane assumption. Through 3 collinear points, there is exactly one plane. All right, let's move on. If I have a cylindrical solid, we've got this set of points between a region and the translation image of that region. I want to show you that this base right here is, for example, an original shape. This base right here could be the translation of that shape. Notice that we simply moved it. And so the cylindrical solid includes all the region between the image and the pre-image, as well as the image and the pre-image itself. Same thing here. I've got my base, and if I translate it to a new shape, a new area, this solid is going to contain the pre-image, the image, and all the area in between. So we're going to say that a cylindrical surface is the union of the bases and the lateral area. For example, here I have 2 bases, I have 2 ovals here, and the lateral area is actually a rectangle. So my surface is going to be the addition of these 3 shapes. Same thing here. I have 2 bases, and if I find the area of those and sum the lateral area, which is a set of rectangles, I will have the entire cylindrical surface. All right, we have some definitions here. The cylinder is a surface of a cylindrical solid whose base is a circle. This is a right cylinder, and this is an oblique cylinder. Notice that here my height is pretty easy to find. Here my height is found at a right angle to the base. The base is, of course, a circle. And your lateral area, if you unfold this cylinder, if I unfold it right here, I've got 2 bases of circles, and then a rectangle is my lateral area. It's important that we've got these terminologies, or these terms down, and we're comfortable with our terminology, because I will call things by these specific words. For a prism, we've got a solid whose base is a polygon, and I've shown us a square prism. So my base is a square. A rectangular prism would have a base of a rectangle. A triangular prism would have a base of a triangle, etc. A hexagonal prism, base of a hexagon, right? And so you're going to find the area of your base to find the total area, and then add the lateral area. Your lateral area is going to be made up of a set of rectangles connecting the 2 bases. We're going to call these pieces right here your edge. I'll refer to the base edge if I'm talking about the base, or a lateral edge if I'm talking about a lateral surface. And sometimes we have oblique prisms as well. And here we'll find the height off to the side as well. Right here, if I have a pyramid and a cone, here I can see that the height makes a right angle with your base, And here's another important point. We're going to call this the slant height. We have the height of the entire pyramid or the cone, and the slant height is the height of the triangles that are on the lateral faces. Your lateral faces each will have area, so if I wanted to find the area, for example, this pyramid, I'm going to find the area of its base, and then the area of the 4 triangles that connect to the top. And so we're going to call h the height of the whole solid, and this height right here of the triangle is our lateral height. Same thing with a cone. This is my height, and this right here would be my lateral height. And of course, we can still identify our base. Here's maybe a better picture of it. I've got my cones with their bases shaded. This line that makes a right triangle with my base is the height. These lines coming down here would be the slant height of the triangle. All right, for tomorrow, I want you to draw a right cylinder, a rectangular prism, a pyramid, and a cone. And then tomorrow in class, we're going to assign some side lengths, and we'll find their surface areas together.